Hi everyone, hope you are doing great. Today we're going to discuss about relative probability. Before going towards the topic, we'll just have a look on some examples to review the previous concept. So we'll take one example here. Suppose we have two coins, and what are the possible combinations for that? What we could get? So since you can see, we can get head head, head tail, tail heads, or tail tail. So now the question is, what is the probability of getting two heads? So since you can see here, getting two heads together, that is the only chance here we are going to get two heads together. So the probability will be 2 over 4, which can be written as 1 over 2. And then what is the probability of two that are not the same? So not same, here you are having same head head, here you are having tail tail. So not same, head and tail and tail and head. So again the probability, it's 2 over 4. So we can simplify this to 1 over 2. Now what is the probability of getting at least one head? So whenever there is at least, so you need to see in the whole combinations, where are you getting at least one head? Are you getting any head here? No. Okay, ignore this one. You are getting one head here, and you are going to get one head here again, and at least one head is here again. So what is the probability for this one? How many times you are getting at least one head? It's 3, so 3 over 4. Since you remember we discussed sample space, so I would like you to pause the video and just represent this data in a sample space diagram. Okay, so here is the sample space. Hope you get something like this one. Okay, so our lesson objective will be, we are going to define experimental probability, and there are some keywords: probability, since you know about that, theoretical, experimental, chance, scale, and events. Okay, let us look at the bag of the counters. So what is the probability I get a blue counter here? So to get a blue counters, how many blue counters are there? We have only two blue counters here. And how many total number of outcomes we have, or the total number of counters we have, which are 2 over 12. So it will be 1 over 6. Then what is the probability I won't get a green counter? So now the question is, I won't get a green counter. So how many green counters are there? It's only 2. So the probability of not getting a green is 10 out of 12. And we can simplify this to 5 over 6. Okay, so what does this actually mean? So I would like you to think about this. What is the actual meaning of this one? If I took a counter out, then put it back, then I did this 12 times in total. So I would expect to get a green twice, a blue twice, and so on. So how many times would I expect to get a red? So you can see here we have, like, how many times we have red? 1, 2, 3, 4, 5, 6, and 7. So the possibility to get a red, the expectation is 7 out of 12. And how many times would I expect to get a yellow? So since we have only one yellow, so 1 out of 12, that is the expectation for us. So this is called theoretical probability. When we but by just looking at this and whatever information we have, and we are creating or calculating a probability, so we call it theoretical probability. But what should happen in theory actually. Does that mean it will always be the case? No, actually it's not. In experimental probability, when we will do a actual experiment, so whether we can get a blue, we can get a green, we can get a yellow, or we can get a red. So we are not sure. It depends on our experiment. Based on experiment, we will find the probability of that one. Okay, let's have a look. Emery picks a counter and put it back. How many times should she get a blue? So if you think about theoretical probability, so she should get 2 out of 12. But when Emily did the experiment, she didn't get any blue. Why was this one? So now it's experimental probability for that. Okay, let's have a look on this example. Mary made a 5-sided spinner like the one shown in the diagram. She used it to play a board game with her friend Sarah. So now, and she threw the spinner 200 times, and she recorded the results in a table here. So side spinner lands on 1, 2, 3, 4, and 5, since you can see the numbers are here. And then how many times she get 1 when she spin this one? So 19 times she get 1, and 27 times she got 2, and 32 times she got 3, and 53 times she got a 4, 69 times she got a 5. Now work out the experimental probability of each number. So now first of all you need to know, you remember, since she threw the spinner 200 times, so the total is 200. Now work out the experimental probability of each number. So if we are going to find for 1, so it will be what, 19 over 200. Probability for 2 will be 27 over 200, and so on for the others. Now how many times would you expect each number to occur if the spinner is fair? So 1 out of 5 of 200. And if you simplify this, so if it's a fair bias, then it should occur at least one number 40 times. But since you can see when we did an experiment, the probability of each case is different. Okay, let's have a look on this example. Nasir throws a fair 6-sided dice and records the number of sixes that he gets after various number of throws. The table shows his results. So number of throws and the number of sixes. So when he throws 10 times, so the number of sixes he gets is 2. When he throws 50 times, so the number of sixes are 4. Okay, so I will just suggest you to pause the video and work on the following questions. Okay, so now the first question is, calculate the experimental probability of scoring a 6 at each stage that Nasir recorded his results. So on the first place, there are 2 sixes when he throws 10 times. So 2 over 10, which can be simplified to 1 over 5, 4 over 50, and so on. We can write these results. Now, how many ways can a dice land? So it's 6 ways, because there are 6 possible numbers: 1, 2, 3, 4, 5, and 6. How many of these ways give a 6? Actually, when it's a, so the number of ways we can get 6 is 1, so it's 1 out of 6. And then what is the theoretical probability of throwing a 6 with a dice? Again, theoretical probability is 1 over 6. If Nasir threw the dice a total of 6,000 times, how many sixes would you expect him to get? So it will be what, 1 over 6 of 6,000, which could be equal to, okay, here is a practice for you. You should practice these questions. Thanks for watching. Have a good day.